Tanmay Sharma. He is a senior engineer, business development, education network, PNR Industrial Automation Private Limited. He has over 4 years of experience in the industrial automation with instrumentation engineering background. Mr. Tanmay is also working as a trainer in the application department, training students, professors, and customers on automation products and programming software, and has trained over 1,000 participants. Under the Business Development Department banner of Education Network, he interacts with colleges, professors, and students around the India, spreading awareness about industrial automation, and is working with over 40 colleges to help them learn about the latest technology. Today, Mr. Tanmay will talk about robots, an integral part of automation system for unprecedented precision in synchronization between robotics and machine control. So delegates, let's welcome Mr. Tanmay.
So all these, in continuation to all these problems, when we talk about industrial robotics, okay. So when we talk about industrial robotics, it is what we discussed till now. I think we all agree on the fact that that robots have become the necessity right now in the industry, and as very correctly mentioned by Mr. Anik in the end, that it's a bus we cannot miss right now. And also by now we understand the fact that a robot can increase the flexibility of a system, and it can also boost the productivity and improve competitiveness in the market, which is a good thing in order to develop even further and develop the products also in further. But let us also yeah, just a second. Yeah, let us also address couple of more points in this particular field. So the challenges what we are facing in the industry regarding the usability and integration of robotic solution. Machine automation and robotics are still largely two isolated ecosystem in our industry right now. So in an environment where we have a machine running with a robot, generally consists of a robotic manipulator, which is controlled by a robotic controller, and then we have a machine which is controlled by a PLC or machine controller, we can simply call it. So these two entities are general. So they do handshake by a defined communication protocol, and which makes the system more complicated and hard to handle. And these two isolated system creates problem in arrangement, in a sense that we are using two control cabinets for them separately. We are having two controllers to control them, and we are having two different interfaces through which we need to access this. And also with involvement of two controllers, we need to have expertise in both the field. One, I need to be an expert in the PLC programming side, and I need to be an expert on the robotic controlling, designing and controlling side. So in order to control both the ecosystem, and which is very rare to find engineers today in the industry who can do both the controlling or both the are comfortable with both the technologies. And this also increases the MTTR of the machine, that is the mean time to repair, because there are two ecosystems. There will be a lot of complexity, technology differences might be there, and because of all these reasons. And one of the biggest challenge in communication is as I already mentioned, that these are two different ecosystems. So between two different the robotic ecosystem and the machine ecosystem, the communication gap is going to be more, because the machine controller is going to talk to the machine, that take a message, pass it to the robotic controller. Robotic controller will update and give the command to the robot, and robot will give the feedback. The robotic controller will pass on the message to PLC. So it will become a little bit difficult, and the delay in communication is going to increase. So when we talk about these problems, what solution we have in the market today, and how can we address all these problems one by one, we are going to discuss in a couple of further slides. So as I already mentioned that the combination of these two ecosystems, that is the robotics part and the machine automation part, is not very easy as of today. And with the concept of machine centric robotics, again I'll explain this term in a little bit more detail in the coming slide. So with MCR, that is machine centric robotics, what we are trying to do is we are trying to combine these two ecosystems to make one solution. And how we are doing it, let's take that in depth now. So machine-centric robotics is large step towards mastering the challenge of modern machinery, what we discussed earlier. So this approach sees robot and machine to become one, and the robot becomes an integral component of the machine. Okay, dramatically it reduces the complexity of the system, because now I have only one system with MCR. Now I have only one system for which I need to care about, and the robotic controller goes out of the picture. Now robot directly communicates with PLC, and it is integrated, and it becomes kind of a peripheral of the PLC instead of being in a different ecosystem. Obviously it boosts the productivity, even because it gives us the possibility to have smaller batch size production also, and the flexibility of robot also help us to reduce the changeover time, or element the products entirely. So with this MCR solution, the advantage what we get, so what we discussed earlier, that we are trying to bring on the robotic manipulator with machine automation, and try to integrate and control both machine as well as robot with one controller, that is the PLC. This also allows us to have high synchronization of all movements, that is the synchronization between the machine, that is let it be a conveyor belt, what we can say, and so the synchronization between the machine, that is the conveyor belt, and the robot increases, because we are reducing the communication delays which was existing earlier. And also we can this will increase the efficiency in terms of communicating with the track system, or with sensors, and machine vision also, it can be integrated with the same system, because track technology, machine vision, all these entities are anyway they can be collaborated very easily with the PLC. So with integration of robot, this becomes more efficient and more productive. Now let's talk about in terms of software. So when we earlier time, so when we used to have two different ecosystem of robot and machine, we need to have know-how of two different platforms. But now with controlling machine and robot with a single controller, we need to have know-how of single platform, and that can be the PLC programming software, that is Automation Studio. So with the same software, we can also program the machine. In addition to that, without having a specific knowledge of robotic programming language, I can still run a robot in a very efficient manner. And we know that in industry that approximately 70% of the people are trained on PLC, whereas 30% of the people have knowledge of robotic programming and controlling. So it is easier to get engineers who can control a PLC rather than a robot. So it gives us even more flexibility in this particular domain. And obviously it will make our diagnostics easy for the future, because there is only one platform, and so on and so forth. Also, the interface of the machine. Earlier, for example, when we used to have a different panel to control the robot, and different panel to control the machine. And now we are not reducing the number of controllers, but now we are also giving an option to control both the entity with a single controller. So let's say if I have a robotic or a mobile panel for my robot. I can control only a robot with that mobile panel, but now I can control a robot as well as the machine from the mobile panel also, as well as I can control a robot and the machine both with automation panel also, which earlier only used to control the machine. So this is the another advantage of having MCR. Also, it decreases the footprint in the machine. So when we are talking about removing the control cabinet as such, removing the robotic control cabinet from the system itself, obviously it is going to reduce the footprint. I'll just show you a small animation in order to see how it can be done very efficiently. So at the bottom, you can see that there is a robotic controller panel. So we are removing that and just putting the same components in the machine cabinet, control cabinet, and here itself we are able to control the robot with PLC, which reduces the footprint and make the system more cost efficient. So in this particular layout, as you can see that there is a let me just have a pointer. Yeah. So you can see here we have a control cabinet, and here we have a robot cabinet, and these two do handshaking with each other in order to control a system. So here I have a conveyor, maybe and robots are working on that conveyor, and this handshaking creates a delay. In the earlier system, it used to create a delay. Now, just a second. Yeah. So now we have the same machine architecture with us, but in addition to this, instead of having a separate robotic controller, now we are directly integrating the robots with the PLCs itself, that is with the controller of the machine itself, in order to reduce that delay in communication or nullify the delay in communication. Not only this integration will help us to achieve all these advantages what we talked about in the past, but this architecture can be further expanded to different levels. If I want to integrate a track solution, if I want to further go ahead and integrate it with more robots, more delta, SCARA and articulated arm, and want to involve more vision system, these flexibilities will be provided because now I am working on one simple platform. So this was more about the introduction, and also BNR right now is currently can accommodate all the ABB and Codeine robots. In 2017 we became part of ABB, and now we can successfully integrate all the ABB and Codeine robots in our system and create a very successful and efficient MCR system for our customer as on today, and working on for future models also incoming. And talking about the portfolio, what is offered by us, we start from a very simple a delta and a SCARA robot, which is 4 kg of payload and 0.5 meter of reach, and it goes to the level of, as you can see here, 45 and maybe more than that, 60 kgs of payload, and even further reach of 2.05 meter. Also, this product portfolio covers the Delta robot with different IP protection, that is IP54, IP65, IP67 and 69, which can be very easily used in food and beverage and pharmaceutical industries. So all these can be very successfully integrated with the PLC system or integrated automation system itself. Okay. So talking about the software part, I think we are running a little short on time. So very quickly, let me cover the software part. So when we are trying to remove the robotic controller itself from the solution, and we are asking engineers to work on the same PLC platform, software platform to control a robot, we need to have some tools, in order to make the life easy. So yeah. we need to make life a little easy. So in order to do that, we have a map technology which is already running in our PLC, and this map technology provides option to an engineer to use the already developed function block in our libraries to control any component. And in this case, our component is robot. So with map robotics, at the core level, we have already all G code and different programming languages included within the software solution, and any engineer can very easily use these function blocks. Then at the technology level, let it be Delta, let it be SCARA, let it be articulated, we can easily control it. And at the level of process, let it be packaging, palletizing, sorting and distribution, the solution is available in map robotics. So with this, what we are trying to achieve is that we are trying to make a robot and make the robotic and machine interaction more easy, and try to bring on everything on same platform. So all the people working in the industry, let it be end user, let it be OEM, let it be engineers, everyone start facing less problems and comes up with a better solution in terms of product. So thank you.